Hello, everybody. Good morning, good evening, good afternoon. Welcome, Mahu. Welcome, guys. Welcome, Paul, Cam, Dan. Nice to see you guys.
Good afternoon or morning, wherever you are.
Hello, thank you for hosting us today.
It's a pleasure. So, guys, when we actually do those past few weeks, I run this Friday event where we get into a common conversation talking about digital twins. Hello, John, and knowledge graphs and how we can build knowledge base for our mental models and solve actually business problems. And today's conversation is mostly about talking about our questions, solving our ideas, sharing our ideas, projects we are working on, things we want to clarify with each other. And I find those office hours in other communities where I'm a member to, these are the most valuable for everyone because we exchange knowledge and we get to know more from what we share. And with your permission, guys, I would start from from people I see on my screen, asking you a couple of things for you. Paul, you're the first. With your permission, would you like to tell us about you? What are you doing? What is your experience building knowledge bases, knowledge graphs, and your most recent project?
So my name is Paul Foyer. I work at a hedge fund. We have, we're looking at using graph databases for describing our investment items and their relationships. Separately, I have some friends that are not associated with work that are looking to build graph databases and leveraging them in the LLM context. So I'm curious to know more about how, different strategies and techniques for doing that kind of stuff.
Thanks for sharing. Matthew, you are the next one. May I ask you, sir, what are you doing? What is your focus and what is your challenge?
Sure, yeah. Hi, everybody. Welcome. Thanks for welcoming me, and hello to New Hampshire. My name is Matthew McNory. I have been involved in graphs for over a decade. At the moment, I'm the principal maintainer of Dgraph. I don't know if you guys ever heard Dgraph. Dgraph is distributed, highly distributed, very large graph database, running it number of defense departments and defense contractors. Recently, Dgraph was acquired by Starry, which is a government contractor, sort of in the aerospace area, and we're working to hopefully make Dgraph sort of the primary data storage technique for their entire platform suite, sort of similar to what Palantir's done. So in the past, though, I had some experience with digital twins. I worked for, as a contractor, I worked for a company in the UK called Twin Labs.ai, who's doing something similar, using basically creating digital twins of all kinds of various facilities and whatnot. And they use Dgraph as the basis for that, for their data. I've created a graph, knowledge graph on Seinfeld, nice app on GitHub. I use Dgraph. I've also I presented a paper at Cornell, or a conference at Cornell, regarding using Dgraph to map out the Panama Papers. So yeah, pretty experienced there. And the reason I'm here is I just want to be a fly on the wall see where people's problems are and try to get some ideas and see how Dgraph might be able to learn from some of the challenges you guys have.
Great, very interesting, and I like the Dgraph approach because it seems that it's quite bigger than the normal node bases we are working mostly, right? And so
Yeah.
stronger challenges.
Sure. Yeah. I mean, it's designed to distribute its shard, its predicates cross cluster. And we have some databases that have trillions of edges running right now. So it's a very large, comprehensive, high-powered graph database.
I already have a couple of questions for you, Matthew, but let's move on to John first, and then we're gonna get on the questions. So, John, would you like to tell us more about you? What are you doing? How do you build?
Sure. So yeah, thanks for inviting me along. I'm in the UK, in the far south, because the surf is good down here. And my background, I've kind of come. I was with Nokia in Finland for a while, in part of the data OS, running part of the data OS team and music and a few things like that, and was heavy into graphs at a point in time. Then I left the space, sort of went off into Web3 and things like that, and it came back to graphs. I guess probably, I don't know, 12, 18 months ago, when it kind of became obvious that, the march of AI, but the approach that AI has, well, the magic show is over, if you like. And actually, there is a much stronger place in the world for graphs now, I think, than has previously been experienced. So I have a project I'm working on at the moment. I kind of help 0 to 1s. Difficult in that space, but I help 0 to 1s. Recently architected. We have an issue in the UK, and I guess it's an issue in many parts of the world, which is an evidence crisis in law, and you know, the idea that evidence is a requirement for proving somebody's innocence, if you like, or guilt or innocence, has become secondary to the machinery of the justice system. And I got involved in miscarriages of justice, and so I've been working on and used graph knowledge to help what is about to become the greatest miscarriage of justice in British history, for a man who spent 38 years behind bars, not for a crime that he didn't commit, but for a crime that never happened. And we used a graph. We ingested lots of data, and we used a graph to build the relationships and eventually use that evidence to get the High Court to refer his case. And he will be released soon. So that has become a sort of a project for me now, which is what I call evidence intelligence. And so I have a prototype project underway, doing working with both, looking at Neo4j. I'm building pseudographs in Mind Studio for doing testing, and I'm working with SurrealDB. They just raised about 40 million recently. They have the biggest investor is CTO of NVIDIA. So I'm working directly with those guys. In fact, we share an office in London to build the back end, or to look at a way to build the back end of this system, which is more graph traversal rather than what you see with Neo4j. Sorry, that's a long story. But anyway, here I am.
Great. Thanks for sharing. Dan, would you like to tell us a little quickly about you, your background? What is the challenge you are working on close to node graphs?
So it sounds like everyone here has a lot more experience than I in knowledge graphs. So I am also operating in the space of law, and but unlike John, instead of looking at evidence and the practice of law itself, I'm looking at law as a reasoning system, especially in jurisdictions that are not common law, where it's judge-made law by tribunals, but rather codified law. So you take the books and you have a syllogism that happens, and that sort of reasoning obviously doesn't work well or perfectly well with RAG, just with getting chunks out and sending them to an LLM. So I'm looking to improve my my RAG system into a knowledge graph, and use that as well for the parsing and retrieval of argumentation. So it's the same idea, except on the legislative side. So how is law made, and then how is law codified so that you can actually have a reasoning engine?
Pretty cool and very interesting. One case in law where I know that the law is quite more challenging than other cases, because it's not about how it is written, but it's also how we translate the context of the law and how we can apply it in every single case. And this is the challenge for understanding well the context from the text of the law. Thanks, Dan. I see other colleagues in the list of participants. Cam, Petros, Ray, would you like to turn on your microphones, guys, and tell us about your background, what you're working on, and what is your most recent challenge on knowledge graphs?
Yeah. Hi guys. I'm Cam, and well, I'm definitely not as experienced as all of you, but I just finished a unit in my undergrad about knowledge graphs and knowledge representation. And right now I am working on a coastal erosion web app, which, well, I want to use a knowledge graph to sort of assess the current coastal hotspots and use it to predict like future hotspots, and sort of use a graph to risk assess the surrounding public infrastructure across the Western Australian coastlines. It's a bit of a challenge, I would say right now. I'm currently in like the background research sort of stage, and just trying to understand the domain of knowledge. But yeah, that's what I'm working on.
Mm-hmm.
Pretty cool. Thanks. And Petros, would you like to tell us about you and your challenge on knowledge graphs?
Hello. I'm sorry for the background. I have 3 desks in my home, and my 2 children use my wife the other desks. I'm based in Thessaloniki, Greece. Actually, I don't have any experience at all. I'm coming from a law background as a first degree, but in reality, I never practiced law. I'm a business consultant, and recently I read a book called Data Intensive Applications of Martin Kleppmann. And from this book, I realized the power of this kind of databases, and I believe this is the future for everything, almost everything, sorry, because we can, with AI, we can use structured and unstructured data and build this kind of new databases, which is close to knowledge graphs. And the application I would like for myself, first of all, is to to upload a lot of information about me, my projects, my aspirations, whatever, and build this semantic perception. And maybe if I see some good outcomes, maybe we can also build a product. So I don't have any experience, but I know that this is the future.
Thank you. Thanks for sharing, Petros. So that's pretty cool, guys. We have colleagues here in this conversation who are new into the domain and we have very well experienced professionals like Matthew. And so it's a nice opportunity to merge the knowledge, sharing our thoughts and suggestions about covering the gaps, I would say. And I guess let me tell you also about my background, what I do. I'm a business consultant. I used to work for, I used to build stuff using low-code tools like Airtable and Zapier, building operational systems for companies around the globe. And the most recent year, I switched my services into learning more about AI and how we can build something really valuable for a business using AI instead of just only the operational stuff and interfaces for them. And I find the term of digital twins being very interesting, since it's also helpful to stimulate a couple of situations before even you live in those situations. And to go to that level, you have to know very well how to build a knowledge base, which is how we can feed into the machine what we know into the business, what our human know into the business, and how we make decisions actually. So I did start learning that. I found it very interesting and fascinating domain to me. And since I have this tech experience and started working with Neo4j first, experimenting, building my first knowledge bases, I created tons of them and killed most of them. And more recently, I worked in a project where I took 15 YouTube videos from a brand consultant, Chris Doe. I took the transcripts and worked for a week trying to build a knowledge base from those transcripts. So the final goal was for me to have a mental model of this person sitting on the other side of my computer, giving me answers about the personal branding, which is a domain I struggle every single day, promoting our services, and every single person who in the business struggles in communicating the services and the personal values into the world. So this is for me. And if someone has a specific question, please feel free to. Yes, Dan.
So you bring up something really interesting, which is this clone of a person's mental model and their knowledge. And so it to me, it begs the question of how do you grow the ontology? Because you don't have access to a subject matter expert. You don't have the ontology out there already. So you have to grow it in an iterative way. I'd love to hear your experience on how you grow an ontology and ensure that you don't have a fragmentation, you don't have drift. How do you do this well?
I think that this is the first $1 million question. Okay, Trace. It's very important from my experience. The way we can do it is putting trackers, collecting the data and feeding them into the model. But the value is generating one step before we feed it into the machine. How we convert the unstructured data into the knowledge base and feed them into there. So, for example, in a project I worked with a team in the past was building client mind. What we did was created triggers every time a client posts on their Slack a message. basically every time a message is posted on a specific Slack channel, every time we have an email conversation, and every time anybody from the client side completes a session that is transcribed. So we have the transcript automatically, and all of these texts feed them to Google Drive for safe place, place for reference, and then we feed them to Claude, analyze it, and return us back a useful report. And that report, we use it into a knowledge base. This is how we try to do it, and we also save the timeline on that. But here, I would love to ask also Matthew, from his experience and his perspective, how would you attach this case, Matthew?
Yeah, I've been through this a few times, and you know what Dan's referring to is just like it's real world, and this is an issue. You have deterministic things, you know, like measurements and text and things, and then you have non-deterministic things. It's how I view it. It's like, you know, you have this framework like I want to classify, you know, these things starting at this level, but then I want to split, and because then it's getting a little bit more like fine grained, the ontology at this leaf, you know. And I've been involved on a number of projects, and unfortunately, it ends up, this happened in both projects. It ends up kind of everyone gets kind of falls back that, you know, throw their hands in the air, screw it, let's just use tags and start tagging the pieces that you're collecting, as opposed to trying to map them to an ontology that, you know, it's one thing if you had an ontology that, you know, you feel very confident about, you've got a number of experts who are constantly maintaining it and updating it, right, using state-of-the-art tools for doing that. There's quite another if you've got unstructured data that you have no idea, you know, what the ontology should be for it. And that's kind of the situation where I think most real-world knowledge graphs fall, where it's just a mishmash of data coming in, and often it changes or it evolves in certain ways. And unfortunately, I've never seen one put together that had a mapped ontology that was perfect. So, I mean, there's some things that you have ontology that's it's not quite deep, you know, and in some ways that really acts the same way as tags. So I don't know, that's kind of my experience in the real world. I've never seen one. I'm sure they exist, but I've never seen one that has data in the graph that was mapped to an ontology perfectly.
I see here on the chat a question from Ray for Dan. Can you tell us more about drift and other challenges in ontologies and knowledge graphs you face?
Okay, well, I wouldn't pretend to be an expert on the thing, but as you incorporate new data, your ontology might start drifting as there are new terms and new entities that come in and new relationships. And so if you have a system that's not static, a corpus that's not static, you start having issues when you do the classification in an automated way, and you have new concepts that come in, like where do they fit in your ontology? You have new relationships that come in, where do they fit on your ontology? And you don't want to have duplication and fragmentation of what you already have. So at least to me, that's one of the challenges. I was thinking of, I mean, the way I was trying to structure my my build of an ontology was through multiple passes through an LLM to extract concepts and then have candidate concepts and candidate relationships, and then pass over again, deduplicate, concatenate all the concepts, relationships, and use those again as candidate sets, and then keep going until there's convergence. But I'm not sure how that sort of workflow would work with a dynamic corpus where, for example, if you got a YouTuber and they make a new video with a new set of concepts, new set of relationships, how do those fit in? And what happens if they start using synonyms? And, you know, how do you ensure your ontology stays fairly static? At least that to me is a challenge, but I don't know if that answers your question, Ray. But I wouldn't pretend to be an expert in this. I have a feeling that both Dimitris and Matthew seem much more well versed in this than I.
Everybody here is to know more than we know before we join this call. So feel free to put, guys, any kind of question. Nobody's an expert. We're just someone who maybe is more experienced than the other one. And the purpose is just to grow together.
You know, there's one interesting thing that if you look at what Claude did with, or in that group, Anthropic did with, they put out this concept of a knowledge of a memory system for an LLM, right? And we implemented it against Dgraph. So basically, it's just and the way it treats it tries to be extremely simplistic. It only says, you know, here I want to store this entity, and I want to store information about it, whether that be an attribute or another edge, right? So it's like a relationship edge. And that's all it ever tried to do as far as maintaining an ontology. Maybe, I guess the point is maybe that's a question for the group. Is the keeping of an ontology important in an age where you have inference through LLMs and other techniques? Like, is ontology even needed, right? So right, that's something that I find quite curious about the memory system that Anthropic put out as a reference, and we implemented it in Dgraph, and sits on top of Dgraph, and I hooked it up to my Claude desktop, and I just started recording things there, and it started building this huge graph. Like, I looked at it in Dgraph, see what it was basically like organizing things and adding them itself. It wasn't relying on me, to say anything. It would tag this person, like, this is a person, this entity, or this is a car, and this is my toaster, or whatever that I said. I bought a new toaster, I put it into the memory, right? You know what I mean? So it was it was self-organizing this knowledge that it was acquiring from me in a way that really did not try to map it in anything other than entities and attributes. That's what could be edges.
Go ahead. Well, I was just gonna say mine was so like my friends who are kind of in a bit of a startup type thing. I mean, one of their interests in using a knowledge graph is partly to reduce their reliance on LLMs, because they're using a lot of LLMs, but they also don't want to, as the context for things grows and grows, they don't want to spend all that money constantly going back over all of the free text that they've collected, and they want to find ways to reduce the size of the context by using the knowledge graph. And I think that's
Sure.
How does that jive with what you'd experienced?
Yeah, from my standpoint, with something that we added to Dgraph a couple of releases ago was semantic search inside the graph itself, so you can actually store vectors in our graph alongside your other attributes and or predicates, depending on how you like to look at it. So in that case, you create your embedding and you put that into the graph so that you can search across the entire graph using similarity search, and then pull the attributes that are related to that. So what we do, like, we have some benchmarks. We run the SciFact. It's like 5,000 scientific articles and basically summaries and titles. Then you just kind of pump that in, and then you can then query against similar sounding, using the power of the magic of embeddings. Or you can kind of find like 5 articles, the top Ks, that are the ones that are most similar to the topic that you thrown into the query, and then you sort of reduced your set of available things that you have to send to the LLM to maybe 5 documents as opposed to 5,000 documents. So it's sort of like this is a very common thing for vector retrieval, in WAG is kind of sort of try to isolate the amount of information you're sending over context.
Yeah, I mean, if I could chip in, I also found, or like what I'm finding is that using a knowledge graph doesn't avoid the use of LLMs. In fact, it's just a different way of feeding the LLM through retrieval. And then to answer the point that you brought up, Matthew, I would say that, even if context increases, and even if we can keep going with those just embeddings and vector search, then at least in my use case, like the issue is exhaustivity, and I want to know all the instances and all the relationships that exist, not just the top 8 or 20 or whatever I put surfaced through top K. I really want to understand the whole neighborhood of a specific concept. And I also find that, and I mean, I might be wrong on this, but that a knowledge graph might allow me to get a sense of the evolution of the knowledge represented in that graph. So as in my case, the law evolves, you would have changes in the knowledge graph, and you could see those in a way that's more accurate than just vector embeddings that you retrieve, and like see how the relationships in the graph evolve. But maybe for a YouTuber, you don't need that. I don't know. Like if you're just, trying to like duplicate a persona, you could probably get by with just using chunks and like getting the tone and the style of a person, and maybe like, surfacing the concept that he talked about. But I feel that if you want to have that reasoning, exhaustive reasoning, and make sure that you've gotten like the exception to the exception to the exception, then like I have a feeling that you need graphs. But I'd love to hear everyone's thoughts on this, because it's a lot of work to implement knowledge graph retrieval system. So
Totally,
quite interesting.
totally true, Dan, and thanks for sharing. From my perspective, guys, working on the project with the YouTuber guy, I realized, because I had to watch first all the videos. Okay, so I had a clue about what he's talking about, which are the values and so on. And since I follow him for a couple of years, I know which are his mostly repeating principles. Okay, so I would expect to have tons of transcripts with repeating terms, repeating principles, repeating codes, repeating suggestions, and so on. And I realized while I was working in designing the scheme of my knowledge base, what I want to achieve is, okay, I want to have a brain with weights. Okay, so the most repeating principle, the most repeating idea should have greater weight. So it should be the first thing that could be used from my model to give a suggestion or give a response back to the user. And how I did it, I processed through the MCP, through the chat, the transcripts, I analyzed them from there, and I asked my Claude to create unique nodes for every single concept, quote, message. These were my nodes, actually. And every time we have a repeating one, give it one more value to increase its weight. Okay? And secondly, if you find something that is similar or close to this as a meaning, for example, personal branding on YouTube is quite similar to doing personal branding on LinkedIn. As a concept or as an idea, this is quite close, but it's not the same, right? So then I said, okay, build a relationship. Give the relationship of similarity, name it similarity, and put into the edge some description explaining why those two things are related with each other. This is not totally scalable. If you go to sizes like knowledge graphs Matthew has worked, because this could be very, very huge. But into my testing, I found that the mostly repeating principles into those transcripts were the source for most of the responses. And I expected it's about how we think, okay? If we emphasize on a specific subject for 2 weeks from our life, specifically that thing, that subject, the third week, we tend to talk and we tend to use the terminology from that subject. It's like we forget the other things, the other knowledge. It's not that we forgot it. It's just the weight is higher from the most recent thing. This is what I realized. And it's not easy to understand, from my perspective again, what is close to each other. So we can have, okay, these are similar things, but it's somehow different. And one way to achieve it is to put questions back to the model before it pushes the data into your knowledge base. So when Claude gave me his analysis report, show me what they say, which are the outputs, which are the codes, which are the books they suggested, I said, okay, then you answer me this question. Is this similar to that one? So it was like having an assistant live working with me, doing the brainstorming. He had to do the trust work. I had to do the validation. And then we pushed them into the knowledge base. And I'm closing that. My learning from this workflow, guys, was that there is no 100% guaranteed workflow to build a knowledge base. What I find is that depending on your purpose and what you want to achieve, you have to adjust your methodology, not only on building your knowledge base, but also building your vector database or building your prompts on every different aspects of your workflow. And at the end, what you're going to have is not something quite general. You're going to have something quite specific, doing one job pretty well. What do you think, guys? Paul, John, Matthew?
Yeah. So I want to just sort of go right back to Matthew's point about tagging, because yeah, I feel that pain, and it's so when you sort of I mean, you begin with I don't know, it's a case in the law, in the stuff that's to do with law, it's kind of fairly specific. So you begin with a taxonomy, and your taxonomy tells you, has those classifications that says exactly what is, and that's, you're almost beginning with tagging, and then you're moving on to that sort of next, that when you're moving into the ontology and the semantics. What we looked at with sort of trying to create evidence intelligence was looking back over data and different databases and things at the time, and looking at what agents are conceivably capable of, and we thought about we went to, or I went to, or referred to Daniel Kahneman's book on thinking fast and thinking slow, and how he breaks. Him and Amos Tversky do a great job of looking at the brain and how people think and things like that, and the type 1 and type 2 thinking, and so that got us to look at different agents, and we looked at, okay, well, how do we look at a way to orchestrate this? And if we have an agent that is interfacing, so we have a data set and we have an agent that is interfacing and looking for specifically for the temporal data, And then we have another agent that is looking for relationships of a particular type, and so on. And then bringing all of that information back into, I guess, a single source. And then, yeah, but we're not. What I can say is this is theory and experimentation at the moment, but it's more about looking at the roles of different data, what we're trying to achieve, what are the roles of different databases, and what is the role of the graph, whether it be something that a graph that sits at further up the hierarchy, and series of graphs, or but anyway, that's just where we are. And sorry, and then looking at and this is where I kind of sort of came together with the Surreal DB guys to look at. I guess one of the things when you look at an ESJ, for example, it's as powerful it is, as great as it is, etc. Is it's how you bring it all together. There's lots of different parts, whereas what we're looking at with Surreal DB is much more traversal of the data. Yeah, sorry, I'm doing a bad job of explaining it, because we're just in an experimental stage. But the point being is looking at what we actually want from the same data, but looking at the stuff that we want to pull from it, whether that be temporal or graph related or whatever.
I see on the chat, Carlo put it URL for avoid tagging ontology and group similar concept base. Carlo, would you like to share more about this and your experience applying this according to this source?
So I'll try. Hopefully my connection is stable. I'm on the train right now. But ideally, what the document is about is a research where you pass a chunk of text to the LLM, and you ask the LLM to extract an atomic fact or one or more atomic facts from a specific text. And from these atomic facts, you derive the key concepts that are these atomic facts. And of course, through time, as the corpus grows, certain key concepts will be reused from multiple atomic facts. So the moment you start looking at the data, instead, for example, for a RAG, instead of querying directly the chunk, you won't query the key concept directly, and you start traversing the graph, going up, trying to understand if the atomic facts related to that specific key concepts are relevant to the question. So you start putting a context with the question. Okay, so you contextualize the question, and you manage to extract chunks of text that are more relevant to the specific question. At the same time, when you start throwing document after document after document, the fact that multiple documents share the same key concepts, they automatically put documents into relationship. So you don't have to build the relationship manually, but it's dynamic created. So in the areas where I work, and it is both legal and generic knowledge management, this has removed the layer of requiring a taxonomy or an ontology, because the taxonomy and ontology are dynamically built and grow. We still based a little bit on the generation of taxonomy based on an initial corpus, But what we've seen is that this corpus starts growing, and the more it grows, the more knowledge managers that work with our product, they go back and they have to rewrite the ontology and fix the ontology. And that has one strong limitation, that when you start looking for something new, where you have literally an empty pocket in your graph, then the fact that you have fixed ontology, it doesn't allow you to go there, because the system, when you query it doesn't have information. Allowing the graph to be generated in a completely dynamic way allows you to explore parts that you may not know you're missing, and you can find it.
Yeah, that's really cool.
Really cool.
Yeah, I definitely want to read that paper. Just look at the abstract; it looks very interesting. Yeah, it's something that we allow in Dgraph, is that you can embed a number, of vectors and associate them with nodes in a graph, and then when you find yourself on a node, you can be like, well, what other nodes are like this, based on the vector that's stored alongside that node. So it's not just like going from top down, like what concepts in the graph match this. It's more, you can also do, like, similar to what Carlo was just saying, you could find yourself on a node and say, what things in this graph are like me, as opposed, so you might get there a different way, through some other query mechanism, and then you say, okay, fine, find me the nearest neighbors to this particular node, based on the embedding that I already have alongside me. It's kind of a cool concept. And this thing with the auto tagging that this paper describes, I think is probably where knowledge graphs will end up going, because like he pointed out, and the paper points out, it seems, is like trying to maintain an ontology for unstructured data is nearly impossible. I think it's my opinion.
It's really cool. Thanks for sharing the paper.
Thanks, Carlo. I put a question here, guys. How, since we're talking about how solving the problem of for the model, understanding the similarity, how do people evaluate the similarity into a concept? Why I'm putting this question here? The way I'm trying to develop working with LLMs is the way I try to explain things to little kids. When we initialize the information to a little kid, we have the responsibility to do it the right way. And sometimes teachers don't do it. That's why brains getting lost in the future, right? So when I am working on initializing the information, I try to explain the similarity. So my question is, how can we calculate it somehow? Similar terms, similar points, concepts, because we're taking for random text, right?
Sure. And would you? Yes, I'll roll.
Well, I defer to your knowledge. You've built this thing for like terabyte scale knowledge graph. So
it also runs on a Raspberry Pi, so that's kind of cool too. But so, oh yeah, it does. Yeah, you can run on a Raspberry Pi. So when you asked Dimitri about, that how similar it is, or that's sort of a function of the similarity search, right? You can compute the distance using cosine similarity or whatever, like how far away is this particular vector from another, right? So then, and that's basically kind of the whole concept of doing similarity search inside, right, vectors. Mm-hmm. So, I mean, I don't know if that answers your question, but so the magic of embeddings, right? That you have to kind of like trust that, if it's very near, then you know that it's very similar, and grain of thought, right? But yeah. Here is the trap. Right. With embeddings, what happens is we take the distance between the vectors, right? Mm-hmm. The points into the vector is generated from creating embeddings, which are serial numbers, from text, okay? Mm-hmm. What if two different things described in totally different text give us quite similar meaning? Yeah,
Well,
you should use a bet. Yes, you should change your embedding. That that the model you're using to create your embeddings. I mean, at a minimum, like 784 dimension vectors, right? At a minimum, right? So yeah, I mean, is it going to happen? Of course, it's going to happen. It's sort of like hash prediction. Okay, it's going to happen at some point. I'm for the years now I've been working on it, I've never been that surprised. Like I've never found one like, hey, this is about oranges and this is about Utah. I've never come across like, wow, that's weird. They're so close. I've never had that happen. I don't know. And I think a lot of the embedding models actually, are really, really rigorous about making sure that that their generation of the vector is is as accurate as possible.
But we answer their experience. The problem I ran into, like this is an example of just a few days ago, where I was looking through my RAG system that has embeddings. The embeddings are fairly good. And I was looking at a concept of the obligation of discretion that a professional has. So you're not supposed to divulge what you know and so on. And so in my query, I had the professional secret. So like, the secret that you've got, client attorney privilege, the obligation of confidentiality. And in the same query, I had, well, please distinguish these three concepts. So the attorney-client privilege, the obligation of confidentiality, and the obligation of discretion. Please distinguish these concepts. And the RAG system works fairly well, except here's the thing. The obligation of discretion happens not just in, for example, the like a professional's obligation in terms of deontology, but it's also something that happens if you're just hired as a barista, right? And so it happens in the employer-employee client relationship, employer-employee relationship, and not just in the attorney-client relationship. So without specifying the narrower domain in which I was, the embeddings were fine. They're correct. It's true. They are obligations of discretion, but we're no longer in the same neighborhood of concepts. And that's where I'm bringing in the knowledge graph, because otherwise you've got good similarity. The similarity is true. And in fact, the model is clever enough with the chunks to be able to say, hey, like this is the obligation of discretion between an attorney and a client, and the obligation of discretion between an employer and an employee, or employee and employer. But even though it separates them, it conflates them in the report that is generated, as in like, here are the other types of discretion obligations that you have. And those are not relevant to the query because they're out of the neighborhood, the conceptual neighborhood. So although the embeddings work fine, it's not oranges and Utah surface when you've got similar terms and similar concepts, but that are nevertheless quite distant in what would be a knowledge graph. I feel that's where like the embeddings might fail.
Good point.
Indeed, yeah, I could see. Yeah, and then I think just a quick thing, way to combat that, as I think you described, is to ensure that you have other predicates that are part of the node that you can distinguish quickly. Yeah, and as a matter of fact, but even like if you're querying the graph, then make sure that you exclude any similarity search from nodes that don't match parameters that you've indicated the predicates must have before querying. Already, it seems like a good combination, like how to combat that probably.
Yeah, well, that's why I'm moving towards knowledge graph, because if you just tag the chunks by domain, you still don't have that that distinction that always will surface properly. Like it happens in other examples. So
right.
That's where like you have to go to those questions of like, what are the edges that connect it? What is the neighborhood in the graph? And then it could actually exclude those things and combat that. It's not really a hallucination, but it's that conflation of concepts.
Right.
Cool. Why don't we do another question? And since we're getting close to the end of the session, guys, I think from my perspective, and of course, if anybody else has another question, let's discuss it. But I find also challenging to evaluate somehow the entire work we've done into our knowledge base. because it's evaluating step by step. It's totally different evaluating it, the entire one, after processing all of our data sources. Do you find any qualitative or any quantitative way to do your checks, and how do you do this check and do your knowledge bases?
So I'll go from my side. For the sources that I work with, is extremely difficult to validate either, especially qualitatively, the graph in its entirety, because we can validate the specific area that you're looking for. So, for example, for certain type of lawyers, there are certain rules of regulation in Italy that has to be applied to certain queries. We can validate them very strongly because they are very precise. The more precise is the area, the more precise can the validation be. But when you start abstracting things, it's too big, the graph, to understand, is it qualitatively good? So we always validate through small chunks where we know the question, we know the answer, and we validate question and answer to make sure that the graph doesn't start deviating from things because of wrong information or wrong notes. And that's, we always look at the small to validate the big.
Good points. Anybody else opinion, guys, to share? Thoughts on that? The way I try to do that while I'm working is just bringing questions to the model. Because this is, I found, the way to evaluate the usability of my model. When I was started, I was looking for a way to count this quality of my work. So I know that my model can give me 70% good responses. But now the way I do is that I just list questions, or I ask the model to create questions to feed them to the model for questioning, and just put the note of, give me also your confidence score. And from the question and the confidence score, if I see a confidence score of, let's say, 85% and above, it means that, okay, he finds a nice place to be confident enough about this, what he says. He found the information, he understands it, and he gave it back. And if I want to evaluate it even deeper, I do follow-up question to the answer. And again and again. Now, designing a mental model, maybe this workflow could be also a separated place, saving the questions and responses and the relationships between the questions and responses, and feed them back to the model as self-trained resource. Because my response back with a new question can also include my feedback. Like, bro, I don't like it. Or I don't think it says here that. Give me your reasoning. Give me your source. Where did you find that? It was learnings, too many learnings, I would say, for this office hours session, guys. For me, I know more than I knew 1 hour ago, and I'm pretty happy for that. Hope for you the same. We're at the end of the session. Is there any last thought, any last suggestion anybody wants to share with the group before we end up?
Well, I can share, just bouncing off what you just said about like reusing and kind of like bootstrapping your corpus. I found that it worked well very at the very beginning, and then it very quickly poisoned the corpus, because as you're testing and as you're using that the responses that are generated, you end up with things that are incorrect, right? And that like you want to give feedback on. Personally, I haven't found a way to incorporate the feedback well. So if you just feed that back into the corpus, you're feeding back like the wrong information, the one that you wanted to correct. So I'd love to know how you incorporate the feedback, not just the response, and how do you actually correct the response when you put it back into your corpus?
By explaining from my perspective why I count it as wrong.
Okay.
So again, I put myself into the teacher's role with the little children. So to train them correctly, we have to explain them why their way of thinking is wrong. And maybe sometimes we have to do it again and again, because if the same error remains in the memory, it creates noise and struggles the model. Definitely,
I get that, but like you've got now a conversation, so you've got multi-turns, and if you just chunk it and feed it back into your corpus, it's going to be, you might miss the feedback in your chunk.
Wait, the process is I have the conversation, right? And the output of those questions and answers, as a result, is fed to the model.
So like fine tune, or are you putting it back into your corpus?
No, separately. It has to be separately as a second source for learning, as a self-learning, because I think that we should not affect the real central information, the central knowledge base. If in the way I'm working at the moment, if I find from the conversation, question and answers, that something has to change into my knowledge base, then I will definitely go and request the update. But first we have the conversation with the model.
Oh, so you get your model to update your knowledge base based on the feedback.
Yes, yeah.
Okay.
And I work a lot using Claude and the MCP server for the reason that I want to focus into creating a knowledge base. I want to avoid the technical stuff. And I need the AI to give me very, very fast his analysis on the text. This is my methodology, okay? So from the conversation with Claude, I asked him what we discussed today, what John suggested for his case, who also suggested a couple of interesting things. So X, Y, Z. And I think this is not correct, what you say to me. I'm telling to my model, because the model didn't understand correctly what John said previously. So I'm correcting him. I think we have to validate very, very well the model, what the model will process into the knowledge base. Because if we start feeding the knowledge base wrong information, we start creating noise statistically.
I think, I think what you're highlighting is very much a problem with the models and memory right now, and it's it is very much a case of trying to hack your way around memory issues. Exactly what you say. We've done a number of different, tried a number of different ways, and now it's nowadays it's like looking at how can we almost separate this stuff out into its own agents with their own models, their own memories, and but it's an issue.
Definitely. Do you find as a nice idea to separate the memories?
Yeah, experimental. Purely experimental. I just don't have an answer for you right now. But we're just facing the same problems, and that is the greater the memory, the greater the greater the memory, and the more we find issues with not, and this isn't just about feedback back into the model. This is just what it relies on over time, and maybe not understanding what's going on in the background with the model, and maybe it's a case of specifically for our legal project and our legal context. It's what we're now doing is which is creating specifically for like family law or corporate law or whatever. We're training models specifically with that on those domains.
Very good thoughts. And I think it's totally worth it to be tested. We don't have to forget, guys, that testing today, it's easier than ever before. It costs only our own personal time, which can be also counted as study time, to be honest. This is true.
Yeah.
I've not brought in here any idea that I didn't test it, or I'm not planning to do a test.
Mm-hmm.
And there is no Bible about how exactly we have to do this kind of things we're doing. Definitely, it depends. There are a lot of dependencies on the purpose of the project, the way we want to work, the stack we are working. So I said at the beginning of this session, I created many knowledge graphs and killed them the same day. It's quite easy to play with that today. So I would suggest to just schedule 1 hour a week, put a random project. If you cannot find a project, ask Claude to give you an idea for a project and just get into that for 60 minutes. I do it and I find it very, very useful. Honestly, it's our internal R&D for our personal businesses, let's say.
Dimitris, this has been very helpful. I thank you for organizing this. Very insightful. I have to run, but I hope you organize another one of these. It's really good to bring people together and share where we are and our experiences and how the challenges that we're experiencing. So, thank you.
Thank you all. Everyone has to run. I'm gonna send you back the video and follow-up email tomorrow, guys. Thanks for a valuable conversation. It was really grateful. Honestly, thank you.
Thank you. Thanks, Dimitri. Thanks, guys.
See you the next one, guys.
Yeah.
Again.
Yeah, 100%.
Thanks. Bye.